Good day everyone. In this video, I'll be demonstrating on how to build a layer 2 network using VLANs and spanning tree protocol. But first, let us build the topology. So I have already added 3 switches, which is the 2916 switches and 9 PCs. So we have 3 PCs for each, and we have 3 VLANs also, which is VLAN 7, VLAN 17, and VLAN 77. So first is we have to connect PCs from each switches. So we'll use copper straight through cable. Connect them with each other. Then after connecting each PCs to each switches, we will now be connecting each switches with each other using a copper crossover. So from S1's FA024 to S2's FA024, and then use another copper crossover cable to S2's FA023 to S3's FA024. And then we will also connect S1's FA023 to S3's FA023. So that connection is our redundant link that will allows us to see STP in action. Now, we will now be assigning IP addresses for each PCs. So VLAN 7 uses network 1, which is 10.130.0.0 with subnet mask of 255.255.192.0, and the usable host range is 10.130.0.1 to 10.130.63.254. And then VLAN 17 uses network 2, which is 10.130.64.0 with subnet mask of 255.255.192.0, and the usable host range is 10.130.64.1 to 10.130.127.254. And then VLAN 77 uses network 3, which is 10.130.128.0 with subnet mask of 255.255.192.0, and the usable host range is 10.130.128.1 to 10.130.191 to 0.214. So before we configure the switches, we will now be assigning these IP addresses to all our PC. So we are using 3 subnets from our address plan. So click on each PC and assign the addresses. So again, for PC0, since it is VLAN 7, and we added the IP address of 10.130.0.1 and then a subnet mask, and then the default gateway of 10.130.0.1. And then we will go with PC3 since it is on VLAN 7 also. And then on PC6, so I am done adding or assigning IP addresses to VLAN 7. Now we will be assigning IP addresses to VLAN 17. So again, since this is VLAN 17, we have used 10.130.64.1 and the default gateway of 10.130.64.1. Then let's go with PC4. Then let's go with PC7. And then I have already finished assigning IP addresses to VLAN 17, and now we'll go with VLAN 77's PC to assign their IP addresses. So since this is VLAN 77, I have used 10.130.128.1 with a default gateway of 10.130.128.1. And then the same with, PC5, since it is on VLAN 77 also. And then on PC8, and also note that since this is a layer 2 network with no router, the default gateway is set to the first usable address of each subnet as a placeholder. So now let's configure the switches, and we will start by creating the VLANs on each switch, and we need to create VLAN 7, VLAN 17, and VLAN 77 on all three switches. Then we will assign each PC facing port as an access port to its correct VLAN, and the links between switches will be configured as trunk ports so they can carry traffic from all the three VLANs. So then go with S1 and then CLI, and then just follow my comments. So we'll now be creating the VLANs. So we will now be assigning access ports. Now we will configure trunk ports, which is to S2, and S3. Then we will save it. Write memory or copy running config startup config, but I will use write memory. So we will now be configuring S2. Now we will create VLANs again. Then we will now be assigning access ports. Switch port. And then we will now configure trunk ports to S1 and to S3. And save it again. Then after that, we will now be configuring S3. So again, we have to create VLANs. And then we will now be accessing, assign access ports. Switch port mode access. Then switch port access VLAN 7. Then exit. Then interface 2. VLAN 17. Then exit. Then 03. And then with 77. Exit. And now we will be configure trunk ports from S2 and to S1. And just save it. Then after that, we will now verify that our VLANs are correctly configured. We will use show commands on each switch to confirm that the VLANs exist and the ports are assigned correctly. So we will show VLAN 3. As you can see, it's active. And then I will also show interfaces from. And then we will load this on S2 too. So all is active. And then show interfaces from. It's 5. And on S3. All is active, and then show interfaces jump again. So everything is okay. Now, let us talk about spanning tree protocol because since we connected S1 to S3 directly, we will now have a triangle of links between our three switches. So S1 to S2, S2 to S3, and S1 to S3. So this creates a physical loop in the network, and without STP, this loop would cause broadcast frames to circle the network forever and crash it. This is called a broadcast storm. So STP automatically detects this loop and blocks one of the redundant ports to eliminate it while keeping the other links active. So if the active link fails, STP will automatically unblock the redundant ports, so the network keeps working. This is what makes STP important, as it provides both loop prevention and automatic redundancy. So let us verify that STP is running and see which port it has decided to block. So we will run show spanning tree on each switch to see STP status. And then on S2. And then on S3. Just click the mark here. And then we will also, to see STP per VLAN, we will also run these commands, which is show spanning tree VLAN 7. This is for each switch. And then 17. And then 77. So on S2. Seven. Then after that, we will go with switch 3. So in the output, we will look for the root bridge. So this is the switch STP elected as the center of the network. And you will also see ports labeled as root port, designated port, or blocking. And the blocking port is the one STP chose to shut down to prevent the loop. So as you can see here in S3, we have a block port, which is this one, which is the FA024. As you can see, we could see the PLK. So it means it is the one that is being blocked. So now let's manually set S1 as the root bridge for all VLANs, so we have a full control over which switch is the center of our network. So let's go with S1. So we will set S1 as root bridge for all VLANs. Spanning tree VLAN 7 root primary, and then spanning tree 7, and then spanning tree 17 root primary, and then 77 also. And we'll just end this and then right now. So we will verify again after setting the root. And then go with S2. And then to S3. So after that, let us verify that our network is working correctly. So PCs in the same VLAN should be able to ping each other across switches, and PCs in different VLAN should not be able to reach each other. That is expected. That is expected behavior of a layer 2 VLAN network. So we will open PC0 and then go to desktop, and then the command prompt. So we will try pinging PC3 and PC6. So they are also in VLAN 7, and the ping should succeed. So we will now ping PC6. So they are all successful. And then how about we try pinging PC1, which is it is on VLAN 17. So it should fail because again, PCs in different VLANs should not be able to reach each other. So as you can see, it fails. So that is all for this video. And again, we have done layer 2 network using VLANs and spanning tree protocol. Good day everyone. In this video, I will build a network by demonstrating three concepts, which is the legacy routing, HSRP, as well as the edge channel. So first is we have to build the topology. So I have already added 2 routers, 3 switches, and 9 PCs. So first is that we have to connect them with each other. So first we have to connect the PCs from each switches. And then we will now be connecting the switches. So we'll use copper crossover cables. Then from S1 FA021 to S2's FA021. And then again, another cable for using copper crossover. So from S1's FA022 to S2's FA022. And then we will now be connecting S2's from S3. So from FA024 to S3's FA024. So as you can see, the connection between S1 and S2 is for Ether channel, and then the connection between for the regular trunk between S2 and S3, and we use copper crossover. So for all, we use copper crossover, and then we will now be connecting our the routers from switch 1. So we'll use copper straight through. So from R1's gigabit 0, and then we'll use fast Ethernet 05. And same with this, and then 06. And then 07. So after that, we will also connect router 2. 08. And then after that is we will now be assigning IP addresses to all our PC, and we are using 3 subnets from our from my address plan, which is VLAN 8 uses network 1, which is 10.130.0.0 with subnet mask of 255.255.192.0, and VLAN 18 uses network 2, which is 10.130.64.0 and with subnet mask of 255.255.192.0, and then VLAN 88 uses network 3, which is 10.130.128.0 with subnet mask of 255.255.192.0. So notice that the default gateway for each PC is not R1 or R2's actual IP address, because it is the HSRP's virtual IP address, which we will configure later. So this virtual IP is what the PCs will always use as their gateway, regardless of which router is currently active. So click on each PC, and then go to desktop, and then IP configuration, and assign the following. Now let's go with VLAN 18. Mm. And then after assigning all the IP addresses for each PCs, now let's configure the switches. We need to create VLANs on all 3 switches, assign the correct access ports to each VLAN, and set up the trunk links between switches. And we also need to set the ports connected to the routers as access ports assigned to the respective VLANs. This is the key characteristic of legacy routing, wherein each router interface connects to the switch as if it were just another end device in that. So let's go with S1 and then CLI. Then now we will be assigning the facing access ports. Then we'll be assigning R1 router facing ports. Wait, so it should be interface FA051. And then switch port mode access. And then switch port access, switch port access, VLAN 8. After that, exit. And then followed by yung FA0 interface FA6. Switch port mode access again. And then switch port access VLAN 18. And then exit again, and then 07. And then we will now assign our two routing facing ports. So interface 08, switch port to access, 8, I mean 80, 07, 08, 8, and then exit, and then 09, exit again, and then 010. $88, then exit, and then end, and then write memory. And after that, we will now configure VLAN, S2. CL, right? Again, we are creating VLAN. Then we will be assigning PC facing access ports. And then 01. And we switch port. This is for VLAN 88. Then exit. Then after that, we will now configure trunk ports to S3. So interface LA024, and then switch port mode trunk. Then exit. And then we will save the configuration. And then after that is we will go with switch 3. And then just do the same. We will create VLANs first. Then 8, in LAN 8. LAN 1, exit, and then VLAN 18, LAN 2, then exit again, and then VLAN 88, and then LAN 2, and then exit. Then after that, we will assign in PC facing access ports. Interface again, and then FA01. Exit. And then we will configure trunk port to S2. Then write it again or save it. Then after that, let's configure Ether channel between S1 and S2. And Ether channel bundles multiple physical links into one logical link. And this gives us more bandwidth and redundancy. So if one cable fails, the other keeps the link alive. And we are using PAGP mode, which is Cisco's proprietary Ether channel negotiation protocol. And we will bundle FA021 and FA022 on both switches into port channel 1 and configure it as a trunk so it carries all the 3 VLANs. So let's go with S1. Channel group. One mode is available. Then exit. And then interface or channel. Interface. So interface. And then switch port neutral. And then exit. And then after that, we will write with the memory. And then after that, let's go with S2. Channel group 1 mode design report, and then exit, and then interface port channel 1, switch port and exit. And exit again, and then write memory. And then we will now verify the other channel. So in S1, we'll show Ether channel something. And then we'll also show use this on S2. And then also use this show interfaces port channel 1. Okay, so as you can see on the result of the show Ether channel summary, we could see the pin next to the interfaces, and this means that the ports are bundled and active in the port channel, and the SU next to the port channel 1 means that the bundle is in use and acting as a layer 2 trunk, and this confirms that Ether channel is working correctly. So now let's configure the routers. In legacy routing, each router interface is connected to a different VLAN through a separate physical cable, and each interface gets an IP address from its respective VLAN subnet, and this IP address also serves as the real interface IP for HSRT, which we will configure right after. So notice how R1 needs 3 separate physical interfaces, 1 per VLAN, and this is exactly why legacy routing is considered inefficient compared to other inter-VLANs method. It consumes 1 router interface for every VLANs that you have. So again, on R1, and then on CLI, this is VLAN 8 interface. Then IP address 10.130.0.10, and then 255.255.192.0. And then no shutdown, and exit. And then in VLAN 18 interface, then no shutdown again, and then that's it. And then this is for interface of VLAN 88. So interface tip 2, IP address 122, then no shutdown, and then exit, and then end, and then right hand. And then we will now go with R2 interface configuration. This is VLAN 8 interface. Get the servers. And IP address. Wait, 0.11, then 255.255.192.0, then exit, and we forgot to add no shutdown. Shutdown, and then exit, and after that, VLAN 8 interface. .11, and then shutdown, and exit, and then for VLAN 88 interface, we use 2, and then IP address 128, and then no shutdown, and then write memory. So after that, let us configure the HSRP, which is the Hot Standby Router Protocol, and HSRP will allow two routers to share a virtual IP address, and the PCs use this virtual IP as their default gateway, and R1 will be the active router, meaning it handles all traffic normally, and router 2 will be the standby router, just waiting in the background. And if R1 fails or loses power, R2 automatically takes over the virtual IP and becomes the active gateway, and the PCs never need to be reconfigured because they always point to the same virtual IP. And we configure HSRP directly on the router interfaces, and we assign R1 higher priority, so it wins the active election. And the virtual IP for each VLAN is the 0.1 address of each subnet, which is exactly what we already set as the default gateway on all the PCs. So let's go with R1 for HSRP's configuration, and then interface gate 0, and then standby 1 IP, standby 1 IP 10, standby 1 IP 10.1 to 3.0.1, and then standby 1 priority 110, and then standby 1 preempt, and then exit, and then interface 601, and then standby 1 IP 10.130.64.1, and then standby 1 priority 110, and standby 1 preempt, and then close, and then exit. And let's go with interface 02, IP address of 128, and then priority, and then preempt, and then exit. And then after I'll write memory, and then we'll go with R2, and then interface 1 gigabit, gate plus 00, and then standby 1 IP 10.130.0.1, and then standby standby 1 priority, 90, and then exit. Then interface, gig 01, then standby 1 IP 64, and then exit. And then interface G02, and then standby 128. Priority, $90, then exit, then end, and then write memory. Then we will now verify HSRP. So we'll show standby 3. So use this. Then after that, we'll go to R2 and verify it also. So show standby 3. So as you can see in the output of show standby drift, you will see R1 listed as active and R2 listed as standby for each group, and the virtual IP address is showing the P address code. So this confirms that HSRP is working. So finally, let us verify that everything is working together. So PCs in the same VLAN should be able to ping each other, and because we now have routers handling inter-VLAN routing, PCs in different VLAN should also be able to reach each other. So from PC 0, we're gonna ping same VLAN across switches. Command prompt. Then we will ping this. So we are pinging same VLANs. And then from PC 0, we will ping different VLAN. So let's just try again. And then as you can see, even if we ping the other VLANs, it is still successful because we have legacy routing active. So that is all for the demonstration. And again, this is legacy routing with HSRP and Ether channel. Good day everyone. In this video, I will be demonstrating on how to configure router on a stick using Cisco Packet Tracer. But first, what is the purpose of router on a stick? Router on a stick is used to allow devices from different VLANs to communicate with each other using only one physical router interface. And for this activity, I will be using one router, 3 switches, and 7 PCs. And I will also have 3 VLANs, which is VLAN 8, VLAN 18, and VLAN 88. So first is that we will connect these devices. So first is that we will use copper straight loop to connect a router to switch 2, so gigabit Ethernet 00 to switch 2's file FA024. And then to connect each switches is we will use copper crossover. So from switch 1's FA024 to switch 2's FA023, and switch 2's FA022 to switch 3's FA024. And then we will the connection between the router and the switch will become a trunk link because it needs to carry traffic from VLAN 8, VLAN 18, and VLAN 88 going to the router. And then the switch-to-switch connection will also be configured as trunk ports, as this is needed because VLAN traffic must pass between switches. And then we will now be connecting each PCs to each switches. So switch 1's FA01, and then 02 to PC 1. To PC 3. and then 03 to PC4, PC5, and then 02 to PC6. Now we will now be assigning IP addresses to each PCs, and I will use this network. For VLAN 8, I will use network address, which is the 10.130.192.0, and subnet mask of 255.255.192.0, and for the default gateway is that we will use 10.130.192.1. And then for VLAN 18, I will use 10.131.0.0 for the network address, and then for the subnet mask, just the same with VLAN 8, and then 10.131.0.1 for the default gateway, and then for VLAN 88, I will use 10.131.64.0 for the network address, and then the same with the subnet mask of the first ones, and then the default gateway, which is 10.131.64.1. And the default gateway is the router sub interface IP address, and this allows PCs from one VLAN to communicate with PCs from another VLAN. So let us assign the IP address. We will go to PC0 in IP configuration. PC1. Then PC2. And PC3. And PC4. Then PC5. And PC6. And then after assigning the addresses, we will now configure the VLANs on S1. First, I will create the VLANs. VLAN. So I created VLAN 8, VLAN 18, and VLAN 88 on S1, so the switch can recognize these VLANs. Next, I will assign the PC ports. This command assigns S1 FA01 to VLAN 8, and this means the PC connected to this port belongs to VLAN 8. And now, for interface 02. Now these commands assign S1 FA02 to VLAN 18. Now I will configure the trunk port going to S2. And this makes S1 FA024 a trunk port, so VLAN traffic can pass from S1 to S2. Next, I will configure S2. But first, we have to save this. Let's go with S2. First, again, is that I will create the VLANs. So I have already created the VLANs for S2. Now I will assign the PC ports. So this again. So this assigns S2 FA01 to VLAN 8. And then this one assigns S2 FA02 to VLAN 18, and then we will now be assigning S2 FA03 to VLAN 18. So 03. And now we will be configuring the trunk ports on S2. This makes S2 FA023 a trunk port going to S1. And then this makes S2 FA022 and a trunk port going to S3, and then this also makes S2 FA024 a trunk port going to the router. And this is the most important trunk link because the router will use this connection to route traffic between VLANs. And then we will be configuring VLANs on S3. But first, let me state this. Let me rename our switch. Then I have to exit first and properly run. And then we will now go with switch 2. Then I will create again the VLANs. And this VLAN must also exist on S3 so it can handle VLAN traffic correctly. Next is that we will assign again the PC ports. I mean VLAN 18, since we have VLAN 18 and 88 only. And this assigns S3FA01 to VLAN 18. Now we will assign S3FA02 to VLAN 88. It should be interface pass Ethernet 01. So let me redo that again. And then 03, I mean 02. And then switch port node access, and then switch port access VLAN 80. And now I will configure the trunk port going to S2. So open port, and then switch port mode trunk. And this will make S3FA024 a trunk port so VLAN traffic can pass between S3 and S2. Now I will be configuring router 2, but again first, as we need to save this. Copy running config. Start config. So now we'll go to router 1. Okay. Go to CLI, just press type and then we have to enable. And then first is that I will turn on the main physical interface. I will also use no shutdown because router interfaces are usually turned off by default. And router on a stick, I do not assign IP address directly to the main interface. Instead, I will create sub interfaces. And each sub interface represents one plan. So interface, a gigabit Ethernet 00, and then no shutdown. Then the sub interfaces. We will create a VLAN 8 sub interface. 0.8. Then encapsulation. Dot 1Q 8. And then IP address 10.130.192.1. And then 255.255.192.0. And then this creates a sub-interface for VLAN 8. So the command encapsulation.1Q tells the router that this sub-interface is for VLAN 8. And the IP address 10.130.192.1 will be the default gateway of all VLAN 8 PCs. And then we will now create the VLAN 18 sub-interface. Let's exit this. So interface gigabit 080. And then encapsulation.1Q80. Then the IP address, just type this IP address 10.1v1.0.1 255.255.192.0. And then again is that this creates a sub interface for VLAN 18, and the IP address 10.131.0.1 will be the default gateway of all VLAN 18 PCs. And then we will now be creating VLAN 88 sub interface. So 80. Then encapsulation.1Q80. And then the IP address 10.131.64.1. And then 255.255.192.0. Is that correct? Okay, so this creates sub interface for VLAN 88, and the IP address 10.131.64.1 will be the default gateway of all VLAN 88 PCs. And then after that is that we will save this first. Then copy running config. Start config. After configuring everything, we will now test the connectivity. First is I will test a device in the same VLAN. So from PC0, we will try to ping PC2, which is also on the same VLAN, which is, as you can see, VLAN PC0 to VLAN 8, PC2 is in VLAN 8. So, command prompt. So open the command prompt and ping PC2 10.130.192.3. So since the pin is successful, it means VLAN 8 is working and the trunk connection between switches can carry VLAN 8 traffic properly. Next is I will test communication between different VLANs. So from PC0, in VLAN 8, I will ping PC1 in VLAN 18. So as you can see, PC1 belongs to VLAN 18. So ping 10.131.0.2. So as you can see, it is all successful, and this is important because VLAN 8 and VLAN 18 are different networks. Normally, devices from different VLANs cannot communicate using only switches, and this since the ping is successful, it only proves that the packet from VLAN 8 is being sent to the router through the default gateway, which is the 10.130.192.1, and then the router forwards it to the VLAN 18 through the sub-interface G0/0.88. Next is that I will ping PC4. From PC4, I will ping PC0 in VLAN 8. So as you can see, first is that PC4 belongs to VLAN 18. And then PC0 belongs to VLAN 8. And then 64 0.2 and then 0.3. So it is successful, and this only proves that the router can route traffic from VLAN 8 to VLAN 88. Lastly is that I will also test PC5. How about PC5 in VLAN 18? As you can see, PC5 is in VLAN 18, and then I will ping from PC5. I will ping PC6, which is on VLAN 88. So open the command prompt and then ping 10.131.64.8. So since the ping is successful, it also confirms that VLAN 18 and VLAN 88 can also communicate through the router. So overall, this activity works because of the router on a stick. Normally, devices in different VLANs cannot communicate using only switches. That is because each VLAN is a separate network. And to allow communication between VLANs, we need a router. And in this activity, I use only one physical router interface, which is G0/0. Then I created sub-interfaces, which is G0/0.8 for VLAN 8, and then G0/0.18 for VLAN 18, and G0/0.88 for VLAN 88. Each sub-interfaces has its own IP address and acts as the default gateway for its VLAN, and the port between the router and S2 is configured as a trunk port so it can carry traffic from multiple VLANs. And when a PC from VLAN 8 wants to communicate with a PC from VLAN 18 or VLAN 88, it sends the packet to its default gateway first, and the router receives the packets, check the destination network, and forwards it to the correct VLAN. That is how inter-VLAN communication works in router on a stick. So that is how we configure router on a stick in Cisco Packet Tracer. Thank you for watching. Good day everyone, in this video, I will be demonstrating on how to create static routing using Cisco Packet Tracer. But first, what is static routing? Static routing is when you manually tell a router exactly where to send packets, unlike dynamic routing protocols like OSPF or RIP that figure it out automatically. But what we will have is a simple tree-router topology, and each router has its own local network, which is the LAN 1, LAN 2, and LAN 3. And the routers are connected using serial 1 links to HWIC -2T modules, which simulates a real-world WAN connection. And our goal is simple, which is for PC1, PC2, and PC3 should be able to ping each other. So let's get started. First is that we have, let me set up the devices. So I need 3 Cisco 1941 routers. Rename it. And then we will be needing 3 2960 switches. And then we will be needing 3 PCs. Now, this is important. Each router needs a serial module. Then we have to click on a router and go to the physical tab and then power it off. And then we will drag the HWIC IC-2P into a open slot and power it back on. And we will do this for all three routers. Now let's connect the devices. We will use, first is that we will connect router to routers. So we will use serial DCE, or we could use serial DDE. But for now, we will use serial DCE. And we will connect routers 1 serial 0/0/0 to router 2's S0 serial 0/0/0. And then we will use again serial DCE to connect routers 2 serial 0/0/1 to routers 3's serial 0/0/0. And then we will now connect router from the switches. So we'll use copper straight through cable. So from router 1's gigabit 00 to switch 0's fast Ethernet 0. And then to router 2's gigabit to router 2's gigabit 00 to switch 1's fast Ethernet 01. And then the same with router 3 00 to switch 2's 01. And then we will now be connecting the switch from each PCs. So from switch 0/01 to PC 0's fast Ethernet 0, and then switch 1's 02 to PC 1's fast Ethernet 0, and then switch 2's 02 to PC 2's. So let me just rename this: switch 1, then switch 2, and then switch 3. And then PC1, PC2, and PC3. So for the WAN links between routers, we use serial DCE DTE or we could use DTE cables, and we connect R1's serial 000 to R2 serial 000, and notice one end shows a clock icon. That's the DCE end, and then we connected R2's at serial 001 to R3 serial 000. And then now we will be assigning IP addresses. I'm using subnets from the 10.130.0.0/15 address space subnetted to /18, and that will give us a subnet mask of 255.255.192.0. And starting with R1, I will click on it and open the CLI and enter the configuration mode. Enable, configure terminal, then rename it. Hostname R1, then interface gigabit Ethernet 00, IP address 10.132.0.1 255.255.192.0, and then no shutdown. Then exit, and then interface serial 000, and then IP address 10.130.64.1, then 255.255.192.0, and then the clock rate 64,000, and then no shutdown again, then exit. So on gigabit 00, this is the LAN interface. I assign 10.130.0.1 with mask 255.255.192.0, and on serial 000, the serial this is the serial interface going to R2. I assign 10.130.64.1 and a sub and the clock rate to 64,000 because this is the DCE side. And of course, we should not forget the no shutdown on each interface. And moving to R2, R2 is the middle router, so it has two serial interfaces. So as serial 0/00 faces R1 and gets 10.130.64.2, and gigabit 00 is the LAN side that gets 10.130.128.1, and serial 001 faces R3 and gets 10.130.192.1, and this is also DCE. So I will set the clock rate here too. So open the CLI, enable configure terminal, then host name R2, interface, IP address 10.130.64.2, then 255.255.192.0, and then interface series. Just repeat it. Interface serial 0, and then IP address 10.130.64.2, and then okay, so and then no shutdown, and then exit, and then interface gigabit Ethernet 00, and then IP address 10.130.128.1, 255.255.192.0, and then no shutdown, then exit, and then again interface serial 001, and then IP address 10.130.192.1, 255.255.192.0, then a clock rate of 64,000, and then no shutdown, and then exit. So finally, we will be configuring RT, which is the serial 000 faces R2 and it will get 10.130.192.2. Gigabit 00 is the LAN side, so it will get 10.131.0.0. Enable configure terminal, and then host name RT, and then interface serial 000, then IP address 10.130.192.0.2, and 255.255.192.0, then no shutdown, and then exit, and then interface gigabit Ethernet 00, IP address 10.131.0.1, 255.255.192.0, and then no shutdown, and then exit. Now let's configure the PCs. But first, I'll just save this. So exit, copy running. Let's go with R2 and save it. Ah, type sectors. Then R2. So after that, again, we will now configure the PCs. We will now click on each PC and go to desktop, then IP configuration, and we will set the IP, subnet mask, and the default gateway. First, just follow my IP address, subnet mask, and default gateway for each PC. So in PC1, our IP address is 10.130.0.2, and the subnet mask is 255.255.192.0, and the default gateway will be 10.130.0.1. Then let's go with PC2, and go to desktop, IP configuration, and again, just follow my IP address and the other details that I will put. So again, for PC2, we have an IP address of 10.130.128.2 and a subnet mask of 255.255.192.0 and the default gateway of 10.130.128.1. Now let's go with PC3. Then follow again the config. Again, for PC3, we have an IP address of 10.131.0.2 and a subnet mask of 255.255.192.0 and a default gateway of 10.131.0.1. So after assigning those IP address, first is that before we add any static routes, let me show you what happens when I try to ping PC3 from PC1. So open the command prompt, then ping the PC1. So as expected, it all fails. That is because R1 has no idea how to reach that network. It knows about its own directly connected networks, but nothing beyond that. This is exactly why we need static routing. So for the main part, we will now be adding static routes. So the command is IP route, which consists of destination network, subnet mask, and next hop IP. Let me explain what that means. So the destination network is the network you want to reach, while the subnet mask describes how big that network is, and the next hop IP is the IP of the next router's interface. So basically, the address where packets should be forwarded next. So on R1, I need to add routes to LAN 2 and the R2, R3 serial link and LAN 3, all going through R2. So the next hop is 10.130.64.2. So first is config T, and then IP route 10.130.128.0, then 255.192.0, then 10.130.64.2. And then IP route 10.130.192.0, then 255.255.192.0, and then 10.130.64.2. Then IP route 10.131.0.0, and then 255.255.192.0, and then 10.130.64.2. So after that, we'll just save this again. So after that, on R2, I need a route to. So after configuring router 1, we will now configure the router 2. And on R2, I need a route to LAN 1 going back to R1 and a route to LAN 3 going forward to R3. So config T, then IP route 10.130.0.0, and then 255.255.192.0, and then 10.130.64.1. And then again, IP route 10.131.0.0, and then 255.255.192.0, and then 10.130.192.2. And then we'll just save this. So after configuring router 2 on R3, I need the route back to LAN 1, and then the R1, R2 serial link and LAN 2 all going through R2. So the next hop is 10.130.192.1. Then IP route again. 130.0.0, 255.255.192.0, and then 10.130.192.1, and then IP route again, 10.130.64.0, 255.255.192.0, and then 10.130.192.1, and then IP route 10.130.128.0, and then 255.255.192.0, and then 10.130.192.1. So just save it again. So after configuring all of that, we will now let me verify the routes if they were added correctly. I run show IP route on R1, and you can see entries marked. We should see entries that is marked with C, and those are directly connected networks. And the ones marked with S are our static routes. And if you don't see any S entries, double check. We will be double checking our IP route commands and make sure that the interfaces are up. So again, on R1, we have to show IP route. We have C, and then we have SSS. So after that is that we will now be test it again. So from PC1's command prompt, we will now ping 10.130.128.2, which is the PC2. So let's just repeat that again. So as you can see, it is all successful. Now let me also ping PC3 at 10.131.0.2. So as you can see, it is also successful. To make sure it is fully working in both directions, let me go to PC3 and ping again the PC1. So ping 10.130.0.2. So as you can see, it is all working, and all three PCs can now communicate through the routers. So that's static routing in actions, and each router only knows about its directly connected networks by default. When PC1 sends ping to PC3, R1 checks its routing table, finds the static route were added, and forwards the packet to R2. And R2 does the same, check its table, find the route to LAN 3, forwards it to R3, and R3 delivers it to PC3 and sends the reply back the same way. And without those IP route commands, the packet would have been dropped because the router wouldn't know where to go. And that's the essence of static routing. You are the one telling the router every possible path manually. That's it for the demo, and thanks for watching.